Okay, after talking about Boyle's Law in the last section, today we're going to start tying in how the air pressure is actually going to affect the weather. And we're going to look at some weather maps and explain what high and low pressure does in terms of the weather. So one of the first things we look at here is that air pressure has weight. The weight of the atmosphere covers a certain area, and that pressure increases closer to the surface of the Earth. We looked at this in a lot in the last section. We talked about air has mass. Okay, when we put the balloons on a balance and deflate at one, the side with air got pulled down. That's because gravity does affect air. We see more air molecules closer to the surface of the Earth. There are some other factors that we're going to look at. We look at cold air being more dense or higher pressure than warm air. And they have here the two columns of air. So we have a cold air column here, and we can see how the particles are very, very closely or densely packed together. Not a lot of space between them. With the warm column of air here, we can see there's a lot more open space here. Not nearly as many molecules in the same area, so it is less dense. And a lot of that has to do with temperature. The warm air being more excited and moving around more can't get as closely packed together in the same amount of space, where the cold air not as energetic and will allow itself to get closer to the other molecules and densely packed together or pushed together a little closer. We look at dry air as being more dense than warm air. A lot of that has to do with the atomic weights of the different gases. So when we look at water vapor, it has two hydrogens and one oxygen, H2O. When we look at its atomic mass, hydrogen has an atomic mass of 1, so we have 2 of those. Oxygen has an atomic mass of 8. When we add those together, we get an atomic mass of 10. Nitrogen has an atomic mass of 7. When we double that, we get 14. And oxygen, we said before, has an atomic mass of 2 or 8. Doubling that gives us 16. Okay, so when we look at the different air molecules that are in here, if we fill a lot more of this space with water vapor, it's going to be like adding a lot of feathers or fluff to this space, where we're adding a lot of matter but not a lot of mass. They're very, very light particles. If we're able to take out a lot of the H2O, we can fit in more nitrogen and oxygen to the same amount of space, and that column of air will be denser or heavier. Because there will be more mass in a smaller, or the same amount of volume. So by adding water molecules, they take up space, but they don't add as much mass to that same amount of volume. So that's why dry air is going to be denser than moist air. Okay. When we look at these different types of air masses that we have on Earth, we have maritime polar air masses. Anything that's going to be maritime polar is going to be cold and moist, like it says there. Anything that's going to be maritime, as we can see here, all the maritimes are forming over water. Okay, and we have our continental air masses forming over land. If we flip over for a minute and we look at a different map here to talk about these different source regions for air masses, we can see that continental air masses are going to form over land or related to the land. Anything that's a maritime air mass is going to be related to the ocean or seas. Polar air masses are going to form closer to Arctic areas and the North Pole, and tropical areas closer to the equator, warm areas, Gulf of Mexico, southwestern part of the United States. So if we come up here to the map, we can look at air masses like F and D, and because they form over large bodies of water, we call them maritime air masses. And near the equator or further down into warm areas near the tropics, so they would be maritime tropics air masses. When we look at E, because it's forming over land, we call that a continental tropic air mass, as opposed to our polar air masses. And with our polar air masses, again, we have maritime polar air masses and maritime polar air masses, along with continental polar air masses forming over land. And that kind of just gives us an idea: are these warm air masses cold air masses, are they moist air masses, or are they dry air masses? And if we go back and look at that PowerPoint, we look at the densities of the air and whether they're high or low pressure air masses, whether they're warm or cool or dry or moist has a lot to do with their pressure as well. So looking at what is denser, okay, when we look at warm air or cold air, we say cold air is denser. When we look at moist air or dry air, we're going to look at dry air as being denser. When we say which air mass would be the densest, we're going to be looking for the cold, dry air mass, and the coldest dry air mass we have here is our continental polar air mass. When we look for which air mass is the least dense, we're going to be looking for the opposite of cold and dry. So we're going to be looking at for something that is warm and moist. Our warmest and moist air masses are our maritime tropical air masses. Some things that we have to remember here is that these air masses have different densities, but they do move around. The air masses are always going to move from areas of higher pressure to areas of lower pressure. And that's a very, very important one to remember there, that we have high pressure air masses moving towards low pressure air masses. As air sinks in a high pressure area, it flows away from the high pressure spot and turns to the right due to the Coriolis effect. Coriolis effect has to do with the Earth. The spin of the Earth is going to cause the air in the northern hemisphere to always turn to the right. So when we have this high pressure area, it's going to spin clockwise as viewed from above. So high pressure areas are going to have air sinking down from high up to the surface of the Earth and spinning clockwise. We have here that clouds don't tend to form with sinking air, so high pressure is usually associated with good, clear weather, or it's going to be very, very dry and sunny. High pressure, dense air sinking, like they have here, lots of sunshine, good weather, very, very dry and sunny. When we start to look at low pressure, we're going to start to look at hot warm air, and hot warm air as it rises, it's going to float on top of the cold dense air or push above. The cold dense air will sink below it because the warm moist air is going to be lighter and less dense and not very tightly packed together. It will be able to float on top of the cooler denser air. Then we call these areas low pressure systems because these is where air is rising up off of the surface, not really pushing down on the surface. So when we look at our low pressure systems, they're going to spin counterclockwise as we go up from the surface of the Earth. Again, the air goes up and to the right, and as it corkscrews up into the atmosphere, it's going to, from above, look like it's going counterclockwise. With hurricanes, we see that they are very, very strong low pressure systems, and they're going to have that counterclockwise spin as they move in the northern hemisphere, especially in the Atlantic Ocean area. That's where we get a lot of the hurricanes that would affect the United States. As low dense air molecules rise, they're warm and moist, they cool and they condense and they start to form clouds. So we get a lot more storms and severe weather or precipitation associated with low pressure systems because there's more moisture in the air. With high pressure systems, there's no moisture, so there's no moisture for clouds to form. With low pressure systems, there's more moisture, so we're going to get clouds forming, and we're going to get bigger clouds forming as well, which will lead to rainstorms or precipitation. So low pressure air rising, stormy, cloudy weather. Okay, we have a quick overview here of high pressure and low pressure areas. High pressure areas cause air to sink, usually resulting in several days of clear, sunny skies, as opposed to low pressure areas, resulting in air rising and clouds forming as water droplets condense up in the atmosphere, and with clouds we're going to be getting rain and storm. So there's some of the big differences. So we look at a little bit of a review here. We have what's denser, warm, or cold air, and that would be cold. What's denser, moist, or dry air, and that would be dry. Which of the following forms a high pressure system, dense or less dense air? We're going to have denser air forming a high pressure system. Which of the following forms a low pressure system? It's going to be less dense air. with the Coriolis effect in the northern hemisphere that causes wind to be deflected to the right or to the left, and that's going to be to the right. In the northern hemisphere, it's always going to cause the air to turn to the right if you were standing from the equator and looking towards the North Pole. Why do few clouds form during high pressure systems? There's not enough moisture for clouds to form during high pressure systems. It's generally very dry air. Why are clouds expected to form in low pressure systems? There's more moisture in the air. With more moisture in the air, we would expect more clouds to form in those type of air masses. What kind of clouds or what kind of weather is expected during high pressure systems? We would generally expect clear, dry, rain-free skies, not a lot of clouds. Sometimes maybe some lower temperatures than we were getting, but clear, sunny skies. What kind of weather would we expect for low pressure systems? Cloudy, rainy weather. Might be warmer, but definitely going to be a little bit cloudy and possibly even raining or precipitating. We have here just a quick diagram to kind of show the differences between high and low pressure again. We look at dry air in high pressure areas descending and sinking down, as opposed to low pressure areas where we see warm air rising up to form clouds. With low pressure areas we see a counterclockwise spin, and we see that warm air rising in the low pressure area to form clouds. With a high pressure area we see a clockwise spin of the air as it sinks down. Because it is denser, heavier air, it is going to sink down. If we think of our hands and our thumb, we can use that to help us to explain whether we have a high pressure area and remembering that it spins clockwise. So if we look at our thumb with the thumbs down, our fingers as they curl, they kind of curl in a clockwise form. So that would help us to remember that high pressure areas spin clockwise, and opposite of that, when we look at a low pressure system, we see the air rising and we get a thumbs up, and our fingers would kind of curl in a counterclockwise form, reminding us that air as it rises in the northern hemisphere would have a kind of counterclockwise spin to it. The last thing that we're going to do is we're going to tie this together with pressure maps. As we start to tie this together with pressure maps, we want to remember that air is going to move from areas of high pressure to areas of low pressure. So looking at this map, we see our highest pressures are 1032, and we see that in a few areas here in the west out near Idaho and Utah, and we see that around Kansas City, Missouri. And we see some low pressure areas out near Billings, Montana. So if we were to say, looking at the Salt Lake area, would we expect wind to move from Billings to Salt Lake or Salt Lake to Billings? We would expect the wind to move from Salt Lake to Billings as it goes from the areas of high pressure to the area of low pressure. Just the same way if we looked at like Kansas City and Buffalo, we see lower pressure here in Buffalo, higher pressure here in Kansas City. So again, we would expect wind to move from Kansas City towards Buffalo. You can also look here at a current weather map for February 1st of 2016, and we can see here how the pressure map for the United States looks, and we can kind of take a look at some of the different areas of high and low pressure. So we have some low pressure here, we have some areas of high pressure here, okay, and we can see some areas here where there is some low pressure, and even just off the map a little bit we can kind of even see some areas of low pressure as well. So we can see we have some low pressure here, high pressure here. We would expect the winds moving from the area of high pressure to the area of low pressure. The other thing we want to point out is where the winds would be the strongest. Where we see a lot of lines of pressure, those are where the winds are going to be the strongest. So in areas like Utah, areas like Wyoming, we're going to see a lot of wind, and we're going to see strong winds in these areas. Where we see very few lines, we're going to see like in Iowa here, we would see very few or very calm winds, if any winds at all. Down here, Florida and Georgia, very, very calm, not a lot of change in pressure, so winds would be very, very low, as opposed to some of these areas. Like we talked about here, Nebraska, Colorado, Wyoming, we're seeing very, very fast winds. And that's about it for our test. If you have any questions, stop by in class.